Good day everyone, welcome to my channel. If you are new, please hit that subscribe button. Today I've got a beautiful paper here that was written from SMU. That is test one. It was written today, the 16th of September 2022. And I want us to do the question one of it, and then part two I'll be doing the application of it, which is to solve system by Ghost Jordan and Kramer's rule and other questions involving inverse and stuff. Well, here it's a multiple choice question. For those of you who have the brain power, you might have seen that this was a takeaway. It was just precisely KFC. So look, let us rate 1.1 and see how far we can go with it. They're saying which of the following is a linear equation or are linear equations. So when we talk about linear equations, we're talking about something which behaves like this, like ax plus by, and then a plus, we can have a cz here if it's in 3D, and then that is going to be equals to 0. Notice that the exponent of xyz is 1. All right, you've got the exponent of xyz, which makes it to be linear. The linear means the exponent of the variable has to be 1. If it was quadratic, you're going to have ax squared plus bx plus c. I guess that you know it's a quadratic stuff. So for linear, you only focus on the variable xyz. Hence, they said in xyz. In this case, we are in 3D. So we don't really focus on our constant bc there. We only look at the variable, which is xyz in this particular case. So they need to have the exponent of 1. In this case, if you look at the first equation, that is a 3x and then a plus 7 to the power 2 over 3y, then a plus 3z is equals to 5. This is a constant. You don't really worry about that. So you only look at your x, y, and z. So those they have the exponent of 1, which makes the first equation to be a linear. So I'm going to say, therefore, this one is in linear version. Now we go to the next equation. That is 4 to the power 2 over 3 x minus 5y, then minus z is equals to 1. That is your constant. Pay attention. Your x, y, z, they have the exponent of 1. So that makes it to be linear. Therefore, both equations are in linear. Now, they want you to pick the correct answer here. So A is in linear. No. I mean, it can be A only and B only. So there has to be both of them. So the answer was this one, number 3. There has to be both A and B. Both A and B true for the equation itself. All right, let's go to the next question. Now they are saying which of the following matrices is or are in reduced row echelon form. So well, when we talk about a row echelon form, we're talking about something which behave like this. In this case, you have how many? Let me check. You've got a 3x4 matrix. So you're only going to focus on the leading one, which is this one and this one and this one. That is your leading one. Above and below the leading one, for it to be a reduced row echelon form, it has to be zeros above and below. So if you check the first column, it's fine. The second column, which is this one, it's also fine. But the third column, you've got a 2 and 5, which makes that to be in a row echelon form. So it's wrong. So A is wrong. All right. It has to be above and below that leading one. It has to be zeros. Now, so A is wrong. We can't really count A. So I'm just going to mark it wrong there. If you look at B, mark your leading one before you get confused. That is 1, 1, and a 1 there. All right. Above and below this leading one here, it has to be zeros. So you can see that B is in a reduced row echelon form. All right. Now you're going to mark the answer as B only. So the answer here, it was B only. All right, now you check 1.3. They are saying which of the following statement is or are true. Number one, which is A, Gaussian elimination involves reducing the augmented matrix of a system of linear equations to row echelon form. This is correct. They are basically saying that Gauss elimination, think about it, it's like you have say maybe you've got a 3 by 3 situation, like 1, 1, and then a 1, you augment it. You can really have anything there. So this is let me just have 0, 0 here and a 0 here, and then here I can have anything. It's fine. We can have any number there. That is row echelon form. We are saying this is a Gaussian elimination. I mean, a Gaussian, yes, very good. A Gaussian elimination. So this is it's a row echelon form. This one, and it's a Gaussian elimination, which is row echelon form. And then now the Gauss-Jordan elimination, it involves reduced row echelon form. That means those stars, they have to be zeros as well. So the B part, it's they are saying Gauss-Jordan elimination involves reducing the augment matrix of a system of linear equations to reduced row echelon form. So that is true. So both of them are true. So you choose the answer as 3, just right there. So the answer is 3. Both of them are true for that one. Now you look at the next question. What are they saying here? 1.4. They are saying that suppose A is a 3 by 2 matrix, and B is a P by Q matrix, and C is a 5 by 4 matrix. If ABC is defined, then P is 2, Q is 4, P is 2, Q is 5, and P is 3, Q is 4. So you can't really guess this type of thing. You have to perform some stuff. Let's check. We have A, B, C. I've got A, B, C. And we are given something. And that is A is, let's check our A. Our A is 3 by 2. And then what is our B? Our B is P by Q multiplied by C. So C is 5 by 4. They are saying if this matrix is defined, what is the value of Q and P? Now, notice that when you multiply matrices like these ones, the number of columns in the first matrix, in this case, we're talking about AB. First, let us look at AB. The number of columns in the first matrix has to be the same as the number of rows in the second matrix. So that means P has to be 2. That means P has to be 2 in there. Let me just delete this one only and delete that one. Cool. So P has to be the same as that one. So I'm going to say P is 2 there. And then now for this one, that guy should really, Q should be the same as what? As 5, because this represent the column, and then now this represent your number of rows in the last matrix. So P has to be 5. So therefore, P is 2, I mean to say, and Q is 5. So you go and check that, and that is number 2. That is number 2 there. That is your answer. Now we say 1.5. Suppose A is a 3 by 2 matrix, and B similarly is the same question, but they are asking it differently. If ABC is defined, then the size of ABC is. So now they want the end result of it. They want the size of it, which means the product. Well, let me have it this side. Let me have it just right here. We have a 3 by 2 multiplied by P by Q, and then multiplied by 4. Let me check. It's what? It's 5 by 4. Yes, that is 5 by 4. So now what you'll do here, you'll multiply these two first, And then let's see what are you going to get. Already we have picked up that P is 2 and Q is 5. So that means we're going to have a 3 by 2 multiplied by 2 by 5. You close that, and then here you've got a 5 by 4. Now check, these two has to be the same for you to multiply. If now you are to consider this one first, so they are the same now, it means the end result will be 3 by 5. So this is going to be 3 by 5. All right, and then you multiply it with this one, so that is going to be 5 by 4. Well, if you observe it from the bird's eye view, you will see that these two are the same. So the result now is going to be what? Let's check our result now. Our result is going to be 3 by 4. So therefore, this is going to be 3 by 4. Or you can do it in this way. Let me just write or, for in case you really want to get that to in the most autonomous sense. Let's just do this. We have 3 by 2 into 2 by 5 into 5 by 4. So I can consider this product and later on multiply with this one. Let's see what are we going to get. I'm just going to keep a 3 by 2. And then now I need to get this product. So what do you get? You get these two guys are the same. So you have to get that result of 2 by 4. So this is going to be 2 by 4. All right. Now these two are the same. They have to give you the end result of 3 by 4. So therefore, this is 3 by 4. So this was the OR method. So you go and check if 3 by 4 is there. Let me check. It is number 3. All right. So number 3 was the answer there. Please, guys, don't forget to subscribe. I'm going to do the last one. I'm going to do question 2 in my part 2. Thank you very much for watching.